This is the second video on Lesson 3.3. We're doing graphing linear equations. The method we're using in this section right here is finding the x and y intercepts. And like I said before, we would prefer to have it in slope-intercept form, but if you're in standard form like this right here, sometimes finding the intercepts is a little bit easier. Sometimes. Okay, to find the x-intercept, I'll let y equal 0. Oh, let's use red. We haven't used red. Negative 2 times 0 is 0, so I have x plus 0 is negative 8. So my x-intercept is negative 8. I discussed in the previous video that for x-intercept you can use A, and for y-intercept we use B. 1, 2, 3, 4, 5, 6, 7, 8. Well, I got lucky. I didn't know if it would fit on there or not. Alright, to find the y-intercept, I'm going to let x be 0. And to do the graph, I'll just draw the line in between. So this one didn't turn out too bad. Pretty easy graph. Another thing I don't like about this way, though, is we don't know what the slope is. I mean, if I wanted to calculate it, I could. It looks like it's going up 4 as we're going over 8. So the slope, I could say, is 4 over 8 if I wanted to. So I guess it's not so bad. I could get it from the graph. That reduces to 1/2. So every time I move over, it should be going up 1/2. It kind of looks like it. Okay. Time to move on to number 20. On number 20, we're going to find x-intercept and y-intercept just like before. On the x-intercept, we'll let y equal 0. It looks like x is 3, so my x-intercept is 3. Right there. To do the y-intercept, I do the same thing, except for I let x be 0. So the y-intercept is 2. Looks like my slope's going to be down 2 over 3, so negative 2/3, but that's not what they asked. They just asked for the graph. See if I can get a good line going here. There we go. Alright, and there's the graph. Alright, beginning with number 21, it just says graph, doesn't give us any instructions on how, and so if we want to use slope-intercept form, we can. On this one, you'll notice the slope is 0 because there's no x term, and the y-intercept is 5. So to graph this, pretty simple. We go to 5 on the y-axis, and since the slope is 0, I'm going to draw a horizontal line, because as I move over, it doesn't change. Let's see if I can. It's not too bad. Look at that. Pretty good. All right. Also, you need to get where you recognize that if the equation is y equals just a constant, the slope is 0, so it's horizontal. You could just draw a horizontal line at that y value. If the equation is going to be x equals something, you can't get it in slope-intercept form, so the slope is undefined, meaning it's a vertical line, and it would be at whatever that x value is. 24 will be an example of that. On 24, we cannot get this in slope-intercept form. You can't solve for y. There's not a y. The slope is undefined because we can't get it in slope-intercept form. And that lets me know it's a vertical line. A vertical line where? Well, when x equals 0. So here's x equals 0. Vertical line is, I'm going to change colors so you can actually see it. I'll do it in red. Right there. 26 is similar to the one we just did. You can't get this solved for y, so you can't get it in slope-intercept form, and the slope is undefined. So what I need to do is I need to find out what x value to put my vertical line at. I'll solve for x. I'll go to 3 at that point, and since my slope is undefined, I'll draw a vertical line. Whoops, got a little itchy there, I guess. There. I'll get rid of that. 27 through 30, we're supposed to match these graphs. It's same concept we was doing before. Each equation only has an x or has a y, and you can't get them in slope-intercept form unless it has a y. So this one's going to be a vertical line because the slope's undefined, and it's a vertical line at x equals -3. So the graph will look like that right there, and that would be D. Whoops. On number 30, I'm going to have to solve for y. I can get that in slope-intercept form. I get y equals -1. So my slope is 0 because there's no x term. See, that's where the slope is. And so it's horizontal, and at y equals -1. So right there, let me draw a line. Yeah, I kind of missed it by a little bit. But anyway, graph matches B. On 27, y is 2, slope is 0, so it's horizontal, it'll be C. On 29, if you added 2 to both sides, you get x equals 2, that would be A. So that was the answers on the other two that was matching. On the rest of the assignment, the only instructions we had was to graph, and you know me, I prefer slope-intercept form, but I think on these in standard form, it's probably easier to just go ahead and do the intercepts, so I'm going to do them really quick. When y is 0, I'll end up with x equals 3. So there's my x-intercept. To get the y-intercept, I'll let x be 0, so I end up with -3y equals 3. Because x was 0, divide by -3, and well, it looks like we have y equals -1. So the y-intercept is -1. I draw my line through. And there's the graph for number 32. On number 34, when I let this be 0, that doesn't go evenly. And when I let that be 0, 3 won't go evenly. So I think I'm going to go ahead and do this slope-intercept form. I've got to solve for y. I should have showed my -3x. -3x plus 5. Divide both sides by -2. Negative divided by negative is positive. So my slope is 3 over 2. And positive divided by negative is -5 over 2. -5 over 2 is the same thing as -2.5. So the y-intercept is at -2.5. And my slope is 3/2. So every time I move over, I will go up 3/2, which is 1.5. Now to get a little better spread out on that, to make that more expanded, I could go up 3. Make sure you realize you're starting in the middle though. 1, 2, 3, over 2, and you'll notice that puts you right in line with the other point. Kind of miss my, yeah, not the best graph I've drawn, but anyway. Positive slope, negative y-intercept.